All right, what's the initial momentum?
Well, the I direction would still be 48, right?
All right, so my initial momentum is 48. Let's go ahead and define. So 48d I hat. What's the j hat initially?
0.
Ooh, I'm using d for two different things there. As long as that. Well, we don't use q for anything else in this course.
So that's just momentum units.
Yeah, I made it up, defined it. It's not one that we use for any other unit. All right, so my first equation. That was drum roll.
P I had,
In other words, 48.
yeah, 48 is equal to 4 times 10 plus 8 times 1.
Wait, say that again?
4 times 10 plus 8 times 1.
Yeah, that is interesting. That's how we got to 48.
Right, okay. Oh, it would be equal to. Four theta, or 4 sine theta. I guess that's what I'm getting at, is that it would be equal to the vectors.
Okay, so we got some component this way, some component this way.
Right.
What is this? The component going this way?
Cosine.
Cosine. All right, so 4,
E cosine.
say it again?
Do we need the 5 in
Yeah,
or
so 4 times 5 times the cosine of theta 4.
I had?
They're all I
Okay,
hat.
this is just the I had. Okay, alright.
Oh, okay.
Plus 8d cosine theta 8.
Yep, one down.
Would it still be equal to 48? Because this is just the I hat vectors, wouldn't it be less than 48, since some of it's going to be the j hat vector?
The whole idea of momentum conservation is what I start with, is what I end with. So since I have 48 in the I hat direction before, I have 48 after, in that direction.
And then what's left over for the j hat?
Well, I got one momentum up and the other momentum down. They're gonna cancel each other out.
Ah, I see that.
So that way we get 0. So, what's my j hat equation? I'll start you out. 0 equals
4 times 5 sine theta 4 plus 8d sine theta 8. Or, yeah,
8
Yeah.
g,
minus.
yeah, minus. One sign off, and suddenly you realize that 1 equals 4. All right, two equations, we got three unknowns, I got theta 8, theta 4, and D. If you don't want to plug in numbers, I've plugged in numbers early on. If you don't want to, that's fine, you could just stick completely with letters. But what is the third equation?
Well, the kinetic energy would all be the same, right? And it doesn't matter what direction.
Right.
So would it be the same as last time?
Yep. So 204 is equal to 1/2 times 4 c squared plus 1/2 times 8 times d squared. Three equations, three unknowns. Oh, actually, we know what c is. So from the third equation, we can actually solve for d, plug that into here. That almost makes it too easy. Let's go ahead and solve it. See what happens. That is 50. That's 4d squared. So I got 154 is equal to 4d squared. If someone would be kind enough to tell me what d is equal to. I assume 6 point something.
.2048.
All right, and so now if we plug that into the first equation, I got 48 is equal to 20 cosine of theta 4 plus 8 times that, which is somewhere around 50.
49.6364.
All right, plus 49.64 cosine theta 8. And then 0 is equal to 20 sine, you know what, I'm going to theta 8. I'm going to go ahead and just take the 8d over, so we have 49.64 sine theta 8 is equal to 20 sine theta 4. Two equations, two unknowns. Now what?
Solve for theta 8 and just isolate that.
Isolate theta 8, is it okay?
Divide by 49.64 sine, or and then do the arc sine of
So that's somewhere around 0.4. Oh, close enough. So sine theta 8 is equal to 0.4 sine theta 4. So it tells me sine theta 8 is going to be, or theta 8 is going to be less than theta 4. Now, I have done one of these problems where it turned out that I set up an impossible situation. So hopefully I didn't do that this time. Doing the arc value here is going to be a little bit tricky because we'd have to do the arc sine of that whole thing, and I'm not quite sure how to do that. I'm sure there's a formula for it, but not my memory banks. So, if I have sine theta 8, just walk through the method. I still have the I hat equation I haven't touched. Or the I hat equation I haven't touched. probably a subjective question, but what's the most important trig identity? Besides the definition of sine, cosine, and tangent,
The Pythagorean,
which is,
sine squared plus cosine squared equals 1.
okay. So from that, if I have sine theta 8, I can find cosine theta 8. Because I know cosine squared theta 8 is equal to 1 minus sine squared theta 8. So we have 1 minus 0.16 sine squared theta 4. So I guess cosine theta 8 equals the square root of that, and actually equals plus or minus the square root of that. Now mathematically, I got a plus or minus here. What would, if theta 8 is negative, what would that mean? Given the way that I've defined over there, what would a negative angle mean?
Go a little bit horizontal.
Except I defined theta 8 already
Oh, as
below the
well.
horizontal.
So we go
That
above.
makes-
Yeah.
So if theta 8 is negative, that means the 4 kilogram hits it, shoots off this way, and the 8 kilogram also goes in the same direction, which we know is not gonna happen. So the negative solution cannot be legitimate. That's a plus sign there. So I now reduce it down to, see, I can divide by 4. So I got 12 is equal to 5 cosine theta 4 plus 2 times the square root of 1 minus 0.16 sine squared theta 4 times d times 6.204. I now have one equation, one unknown, which makes it sound so much simpler than it actually is. But if I've got a cosine and a sine of the same angle in an equation, how do I go about solving that? And a radical to boot. And I'm just going to tell you that I didn't care for these math problems. So if you see one like this where you have a radical and a sine and cosine at the same angle, that just means I was in a bad mood when I wrote the test. Or I made a careless error, which is probably more likely. So how do you solve that? Let's deal with the radical first. How do you deal with the radical in an algebra equation?
You could just square it,
What do you have to do first though?
isolate.
Yeah, isolate it. All right, so we have the radical of 1 minus 0.16